Hello friends, welcome to another math class. Today in our lesson, we'll be looking at division of numbers by multiples of 10 and 100. Division of numbers by multiples of 10 and 100. First of all, I'd like to quickly run through what we mean by multiples of 10 and 100. By multiples of 10, we mean those numbers that 10 can divide without a remainder. And by multiples of 100, we mean those numbers that 100 can divide without a remainder. So examples of multiples of 10, for instance, would be 10 itself can divide itself without a remainder, 20, 30, 40, and so on. Okay, but in this case, when we are looking at the multiples of 10 to divide other numbers, we'll be stopping at 90. And then when we start looking at the multiples of 100, using the multiples of 100 to divide other numbers, we'll consider probably from 100 to 900. Okay, so these numbers and multiples of 10, even all these are also multiples of 10, but we're trying to separate them, distinguish between those we want to use for 10 and the ones we are trying to use for 100. So for a start, we are going to look at some numbers being divided by the multiples of 10. So first example here would be, let's say, 314 divided by, let's start with 10. Let's start with 10. Okay, so let me just quickly say this. There are different ways we can go about this. Okay, if you want to use long division process, it is okay, you can, but then there are other faster ways. Okay, so I will just quickly use the faster way here. Now, in the case of a number like 10 that just has 1, the digit 1 and 0, it will just be, you do that if you like, you can write it like that, and then when this 0 goes, what it means is, okay, before I actually say mention what happens now, let me state here that, let me put a 0 back. Let me state it quickly that every number you see, every single number you see has a point at the front of it. Every number, every whole number has a decimal point in front of it. But it is not written because it really doesn't matter if there are no other digits coming after it. So, but just have it in mind that any number, any whole number you see has a decimal point at the end of it. It has a decimal point. Okay? So this 314 you are seeing actually has a point in front of it. So what happens when you try to divide it by 10? This point, this 0 goes, and this point moves one step backwards towards the left. So what you now have would be 31.4 over 1. Whenever you're dividing a number, if a 0 is a part of the digits that form the divisor, when 1 0 goes, the point moves one step towards the left. If it's 2 zeros that the divisor has, the point will move 2 steps towards the left. Okay, so please, 2 important things I want you to take note of. First here, before we continue, every number you see, every whole number that you see has an imaginary decimal point. Imaginary or not, or let me say invisible decimal point. It's not written because it actually doesn't, it's not important. It doesn't hold any value. when the number is a whole number. But then when there is a fraction being added to that number, you begin to find out that that point is actually important. So we have here 314 divided by 10. So for you to better understand, let's bring the point out. Okay, that invisible point that is always at the end of every whole number, we bring it out so that you will understand what we are doing here. Now, whenever you are dividing by a multiple of 10, if it is 1 0 that the number has, that invisible decimal point moves one step backwards towards the left. If it is 2 zeros the divisor has, as you cancel the 2 zeros, the point will move 2 steps towards the left or 2 steps backward. If it is 3 zeros, it moves 3 steps. So depending on the number of zeros the divisor has, that will determine the number of places the decimal point will move towards the left. So in this case, because the divisor has just 1 0, it moves only 1 step towards the left, and it lands between 4 and 1. So this is what we have here, 31.4 divided by 1. So remember, the 1 is remaining. But we know that any number divided by 1 remains the same. So our answer is 31.4. 31.4. Let me take that up. 31.4. Okay, so we're going to take another example. So the next example we're looking at here is 536 divided by 20. Remember, 20 is a multiple of 10. Okay, so we're still going to do it the same way we did the first one. We can just do 536 divided by 20. And remember what I said about 0. So there's an invisible decimal point here. Okay, so as I cancel this 0, the point moves 1 step towards the left. So the point now lands between 3 and 6, so you have 53.6. And that is over 2 now because the 0 is gone. Okay, so let's use the cancellation method of division to finish this up. So 2 divides 1, 2 cancels 2, that's 1. So 2 cancels 5, we have 2. There is 1 here. This becomes 13. 2 into 13, that's 6. There's a remainder of 1. So that 1 is transferred to this other point. So you have your 26 point. Remember, your point is very important. So this 6 now, because there is a 1 that has been moved to this point, we call this a decimal number system because every number that you carry has the value of 10. So this 6 now plus this one becomes 16. This one is a tens value, it has tens value. So this 10 plus 6 becomes 16. 16 divided by 2, that gives us 8. So your number is 26.8. Now, I will quickly use the long division method here in case there's somebody that is not comfortable with this method. Okay, so let's use the long division method. It's also what you can use. So you have 536 divided by 20. So we know 20 can divide 5, so we take the first 2 digits. 20 to 53, we have 2. 2 times 20, we have 40. Now we subtract. So we have 3. 3 minus 0 is 3. 5 minus 4 is 1. So we bring down our 6. We have a new number, which is 136. So how many 20s can we get from 126? We can get 6 20s. 6 times 20 is 120. So if you subtract, you have 16, and 3 minus 2 is 1, and this is 0. So we have a new number, which is 16. Now we have no other number to bring down here, and we know that 16 is smaller than 20, but we still want to continue with our division. We are not stopping here. So what do? We bring a 0, okay? I joke with my kids. I tell them something like, you bring in 0 from outer space. And because when you are in space, the earth looks like a dot, you put your dot right there. You went to space to borrow a 0, and then from space you saw that earth looked like a point. So every 0 you introduce like this, you put your point right there where your answer is appearing. You have to put that point to show that what you have left is not up to your device, so you had to borrow a 0, you had to bring in a 0. So now we have a new number, which is 160. So how many 20s can we get from 160? Just look at 16. How many 2s can you get from 16? Is 8. Then you add, that's your answer, because there's 0 here, there's 0 here. Forget about the 0. 16 divided by 2, that gives you 8. So 8 times 2, 16, and your 0. That means 8 times 20 is 160. Now there is nothing left to carry or bring down. We have reached the end of our division. So if you look at the answer we got here, 26.8, this is what we got here, is exactly what we got over here. So I don't know, it just depends on whichever is more convenient for you. You can work with it, okay? But for the purpose of this lesson, we're actually trying to focus on this shorter one. I believe this is shorter and more straightforward. Just know how you move your point, how you introduce your point, or when your point comes in, okay? So let's take one example from division of numbers by multiples of 100. So the example we'll be looking at in this category of multiples of 100 is 942 divided by 100. So we arrange our numbers, the dividend on top and the divisor below. Now remember the way we said that the disappearance of 0 down introduces the movement of points at the top. Okay, we said if there is just 1 0 in the divisor, it moves the point 1 position towards the left. If it's 2, it's 2 positions. It's the same rules that apply here. Exactly the way we worked with the multiples of 10, exactly we're going to work here with the multiples of 100. So if we look at this place, we have 2 zeros. And like I said, every whole number has an invisible decimal point in front of it. So with the 2 zeros here, this 1 and 2, this point is going to move 2 places, 1 and 2. So it's going to move 2 places to the left, and it will land at the first place it moves. It will be between 4 and 2. By the time it moves to the second position, it will be between 9 and 4. So the new number we have here will be 9.42 over 1, because the 2 zeros are gone, and any number divided by 1 remains the same. So the answer is 9.42. Okay, so that's the answer. So let's take one more example in this group, and that will be 8 for today. Okay, so here we have 2,469 divided by 300. Remember, we're dividing by multiples of 100. So we have 469 divided by 300. Okay, so here we're going to, let me take it back a little so that we have enough space to work with. 469 divided by 300. Again, we have 2 zeros, and remember what we said about the points moving, so our invisible point becomes visible, right? So what do? You cancel your 2 zeros. That means the point is moving 2 positions to the left. So 1, 2, it stops there. Our point now comes between 4 and 6, so it becomes 24.69 over 3. Remember, our 3 is still there, okay? Only the zeros are gone. So the new number we have now is 24.69. Please don't make the mistake of calling numbers like this 69, the normal names you call whole numbers, because any number that appears after the decimal point is a fraction, no matter how large the digits appear. So this 69 is not 69, but it's 69. So you say 24.69. So now let's divide that by 3. We are using cancellation method as usual because it is shorter, it's faster, and it's more ideal for this kind of division. So 3 divides 24, that gives us 8, right? Remember your point because there's no remainder. So 3 divides 6, that's 2, and 3 divides 9, that is 3. Nothing is left. So our final answer is 8.23. If someone feels more comfortable with the long division method, it's still okay, provided you know how to go about it. If you know how to do your the issue, why I try to stay with this is if you use the long division methods, you may have large numbers in your hands, okay, and you may find it overwhelming if care is not taken to deal with. That's why I chose this cancellation method for this, and I believe it is more ideal than using the long division method. It's more straightforward, okay. So the important thing here to note is the decimal point that gets introduced when your zeros disappear. Once you get a hang of that, you find that it's easier and less bulky to deal with than the long division method. Okay, so I hope we've learned something. I hope to see you again next week. Stay blessed and stay safe.